What is up people, this is Teja, and in this video let's talk about Docker, how it works, how it provides isolation, and why you should always use it whenever you can. So first of all, what is Docker? So Wikipedia says that Docker is a set of platform as a service products that use OS level virtualization to deliver software in packages called containers. Now let's try to understand this. If you look at this image right here, it basically sums up what Docker does. So this is a machine, and the infrastructure refers to the hardware of the machine, and on top of the hardware sits the host operating system, which can be Windows, Linux, or Mac. And on top of the host operating system lies the Docker engine. So basically what this tells is Docker is installed on your operating system, and from Docker you can run multiple apps as container. As you can see, app A, app B, app C, all of these are running simultaneously at the same time through containerization. And what you can also kind of get from this picture is that all the apps that you spawn up with Docker as containers all share the same kernel, which is the operating system's kernel. And this is very unlike virtualization, virtual machines. You can see on the right side is a system that is configured to use virtual machines, and on top of the infrastructure is a software called hypervisor that allows you to run multiple virtual machines on your computer. So you can see this is not sharing the OS or the host operating system's kernel. And usually when you are configuring or setting up a virtual machine, you predefine the resources for that virtual machine, like the number of cores that you want the virtual machine to use, the amount of memory that you want to use, etc., etc. But that is not the case with Docker or containerized applications, because they all share the same kernel, the operating system's kernel, and they share the resources, and you don't have to predefine what resources you want a specific app to use. And another great thing about Docker is that it provides isolation, just like a virtual machine. In this example, app A cannot interact with app B or app C or any other apps that are spawned up through Docker. They are completely isolated from each other. So if you were to run, for example, if you're doing malware analysis on app A, it doesn't affect your host operating system or the other apps that you spawned up with Docker. So it allows you to work independently without affecting your host operating system or the other apps that are simultaneously running on your Docker engine. So using Docker is obviously much more secure than just running an app locally. For example, if you want to run a web server like Apache, you can run it locally or you can run it through Docker. And if you run it through Docker, it is completely isolated from your operating system and the other apps in your Docker. So if, for example, a hacker manages to compromise your Apache web server, he wouldn't be able to escape the container that the app is running in. In other words, he cannot escape from the container to the actual host operating system. So your actual machine is actually safe even though one of your Docker apps is compromised. And we will actually see that example in this video. But before that, let's try to understand how Docker achieves isolation. And the answer to that is by using Linux namespaces. So there is this wonderful article that I found, and I will leave the link in the description below. You can go check it out. It basically explains how Docker achieves container isolation using Linux namespaces, of course. So let's do some hands-on with Linux namespaces and see how containerization works with Docker. So I'm going to make use of a Linux command called unshare, and if you look at the man page, the manual of it, it says that the unshare command creates new namespaces. So using unshare, we can create new Linux namespaces, which we will do. So I'm going to type in unshare here, and I'm going to type in URPF. So basically U specifies that we want to create a UID namespace, and we will understand the difference between these different kinds of namespaces soon. But U specifies that we want to create a user ID namespace, and then R tells it to map the user who is running this unshare command to the root user inside the created namespace. So for example, if I open a new terminal and if I type in who am I, this is my current username. So what R does is that it maps this UID to map to the root user inside the created namespace. It's as easy as that. And the P flag tells it to create a new PID namespace. You can actually find this information in the manual page. You can see -P creates a new PID namespace. And finally, the F flag is going to fork this particular command that we are executing, and it's going to make it the init process inside the new namespace that we are going to create. So basically, it's going to make it the first parent process inside the namespace. And then we will also give another option called mount proc. This option is going to mount the proc directory in the new namespace. And that's it. So if I hit enter, you can see I am now inside a new namespace. If I type in who am I am no longer Teja, I am now root. And you should not mistake this root with the actual root of the whole machine, because it's not. It's not the root of the whole machine. It's just the root of the created namespace. It doesn't really have any real privileges on the machine itself. And if I type in PSEF, there are only two processes running. The first process with the PID 1 is the bash, which is basically this command that we executed. As I already said, the F flag is going to make this as the first parent process, which it actually did. So if I actually type in PSEF in a new terminal outside the namespace, you can see there are a lot of processes running on the actual machine. But here inside the namespace, you can only see there are two processes, and it cannot see outside the namespace. That is the whole point of containerization. And we were also creating a user ID namespace with the U flag. And to cross check if that actually worked, let me try to print out the UID map of the current process. This file right here contains the UID map, which means how the user IDs are mapped from outside the namespace to inside the namespace of the current process, which is the current bash process, the parent process that we have just seen. So if I hit enter, you can see the UID 0, which means the root of the namespace, is mapped to the UID 1001 outside the namespace. So if I go outside the namespace and if I type in ID here, you can see 1001 is actually the UID of the user Teja who executed this command. So in other words, what this is basically telling is that this UID is mapped to the UID 0, which is the root user inside the namespace. So it tells you that we do not have the root privileges on the whole machine. We only have the privileges of the user who invoked this command, which in this case is Teja. And that is the idea behind containerization. Docker makes use of 6 namespaces like this. You can see we have already seen the PID namespace, we have already seen the user namespace, and we have also seen the MNT namespace because we mounted the proc directory using that. And then we also have the net namespace for managing network interfaces. We have the IPC namespace for managing access to the IPC resources. And then we have the UTS namespace for isolating kernel and version identifiers. So now let's try a hands-on with Docker. Let's actually create a Docker image and then spawn a Docker container from that image. So let me go ahead and create a new Apache Docker image. I'm going to create a new directory, call it Apache_Docker. I'll go inside that. In order to import a Docker image to your machine, you can either pull it or, in other words, download it from Docker Hub. If you go to hub.docker.com, you can see there are lots of available images. For example, you can see there is Postgres, Nginx, Python. These are all the official Docker images. So for example, if I wanted to use Python, I can just make use of this command, docker pull followed by the name of the Docker image. And that's going to download that image to my local Docker engine, and then I can create new containers of this Docker image. Or you can create your own Docker images from these already available images by changing the configuration and whatnot. You can basically customize these images that are already available on Docker Hub, and you can create your own Docker image out of it. And that is what we're going to do now. We're going to create a new Apache image with our own custom configuration. So let's go ahead and do that. In order to do that, in order to create your own Docker image, you first need to create something known as a Docker file. So let me go ahead and create Docker file. And since I want to use Apache, I will go ahead and search for HTTPD. And this is the official Docker image that I will be building my Docker image on top of. So I'll type in from httpd, which is the name of the image, colon the version that I want to import, which is 2.4.49. And then I want to customize my Apache app by giving it a custom configuration. So I have a pre-written configuration that I want to use for my Apache app. This is the configuration that I want to use, and it is inside a file named httpd.conf. So I will just move this file to this image, and I will do that by saying copy followed by the path of the file that I want to copy, which is in the current directory named as httpd.conf, and I'll copy it to user local apache2/conf/httpd.conf, which is the default directory where this file would exist when the image is created. So that will be all. That is all the customization that I wanted to do to my image. So I will now save this file, and now it's time to build the image from the created Docker file. And I'll do that by saying sudo docker build-t, and I'll name my image. I'll name it as apache_docker, and I'll say dot because the Docker file exists in the current directory. If I hit enter, this is going to go ahead and pull the Apache image from Docker Hub, and then it's going to set up my image. So if I say sudo docker image ls, it'll list out all the Docker images that currently exist on my machine. So you can see apache_docker is the Docker image that we have just created. And in addition to that, you also see the HTTPD image that was pulled from Docker Hub. Now it's time to actually go ahead and run a container of our image. I will do that by saying sudo docker run -dit-p 8080:80. So basically, when you run a container of this image, it's going to create an instance of the Apache with the custom configuration that we just did, and it's going to make the app available on the port 80. But since we are outside the Docker container, we are trying to use it from the host operating system, we will not be able to use that app on port 80 because port 80 is inside a namespace. And if you want to use it from outside the namespace, or in other words, outside the container, you will have to map it. So I am mapping my port 8080 to the port 80 inside the container. So when I do this port mapping, I will be able to access the app by going to the port 8080, which will redirect all the traffic to the port 80 inside the container where the Apache server is running. I hope that's clear. So yeah, that'll be all. So if I run this, I forgot to actually mention the name of the image that I want to run. So this is the name of the image. I'll copy, paste it, and that'll be all. If I hit enter, you can see the container is now active. And if I go to my browser and go to http localhost 8080, you can see I am now able to access the Apache web server that is running inside the container. And the thing about this app is that it is vulnerable. If you Google for Apache 2.4.49 exploit, you can immediately find out that this version of Apache server 2.4.49 is vulnerable to path traversal and remote code execution. So the app that is running inside the container is actually vulnerable. And let's see if we can make use of this vulnerability to do any damage to the operating system. And we should not be able to do so because the app is running securely inside a container, which is isolated from the operating system and the other apps. So I'm going to go ahead and execute this curl command right here, which is going to exploit the path traversal vulnerability. So basically what I'm trying to do is I'm trying to read the etc/password file by making use of this path traversal vulnerability that exists in the app. And you can see the URL is 127.0.0.1.80.80, which is where the vulnerable instance of the Apache is running. So let me go ahead and execute it, and you can see the response that we got is actually the content of the etc/password file. Is it actually the etc/password file of the host operating system? Let's find out. So if I type in etc/password, and remember I'm not inside the namespace right now, so this should print out the etc/password of my actual machine. So if I hit enter, you can see the contents of this file are clearly not the same as the response that we got. And that is because the Apache server is running inside a container, and this is not the real etc/password file. It belongs to the container, which is completely isolated from the host, from the actual machine. So now you kind of understand how this can be useful, right? How it can be very useful when it comes to running apps securely, because they are isolated. So even though if a vulnerability exists and if an app is compromised, the attacker would not be able to do any damage to the host. Unless, of course, if there is a vulnerability in Docker itself. So what if you can take Docker one step further with Kasm Workspaces, the container streaming platform? So Kasm basically allows you to stream your Docker containers directly from your web browser. So you don't have to execute commands on your terminal, none of that. You can just directly install Docker images on your Kasm Workspaces, and then you can spawn numerous containers of those images, and you will also be able to access them or stream them directly from your web browser. So all you need to have is just a web browser, and you can use your Docker apps from your web browser. This is such an awesome software, and let me show you how to use it. The community version of Kasm Workspaces is available for absolutely free of cost, so you can just install it and get started right away. So here is the official installation guide for Kasm Workspaces. So you can install Kasm locally on your Linux machine, but I'm going to install it on my AWS EC2 instance. You can see I have created an instance and I've already logged into it via SSH. And this is an Ubuntu instance, and I'm going to install Kasm in this. It's very easy to install Kasm. All you have to do is execute these 4 commands. So I'm going to copy all these 4 commands, come back to my SSH session, and I'm going to create a new file called kasm_install.sh. And I'll paste all these 4 commands here, save it, and then run it with sudo like this. And this is going to download and install Kasm on this machine. So I'm going to pause the video here and I'll be right back when the installation is done. All right, so once the installation is done, you can see it also prints out the credentials. So you can actually copy all these credentials and save it in a text file. I'm going to create a new text file called kasmcreds.txt. And I'm going to save these things here. All right, so if I go back to my browser and I'll go to https:// followed by my instance's IP address, click on advanced, click on proceed, and now I can access Kasm Workspaces from my browser. So I'll have to log in with the email and password, which are displayed here. The username is going to be admin@kasm.local. I'm going to copy that, paste it here. And this is the randomly generated password. I'll paste that as well. Click on login. And now I'm logged in to my dashboard. Now there are lots of options that you can configure. For example, you can manage your access management. You can create new sessions of your Docker image, and you can even share or cast those sessions to others by sending a URL. And you can do a lot of cool stuff with Kasm. So I'm going to go to Workspaces here. By default, there are no workspaces installed, but if you click on Add from Registry, you can see a list of Docker images that you can install to Kasm right away. For example, let me go ahead and install, let's say I want to install Google Chrome. So I'll go ahead, click on Install. And what this is going to do is that it's going to pull the Docker image of Google Chrome and it's going to set it up on Kasm so that we will be able to start a new session, or in other words, a new container, and stream it directly from our web browser. So if I go back to Workspaces here, you can now see there is a new workspace, which is Google Chrome, but it's not ready yet, as you can see, because the image is still being downloaded. So the Google Chrome image is now available to use. So I'll click on it, and I will open a new session in a new tab, click on Launch Session, and this is going to open up a new tab in my browser, and look what happens now. A new Google Chrome instance has spawned up in a container, and we were now able to access it directly from our web browser like this. How cool is that? I'm able to access or use my Docker apps from a web browser like this. And if you click on this little arrow icon right here, you can see a lot of options that you can use. For example, you can share the clipboard between the host and this session. You can download files, you can upload files to the container, and you can even go ahead and share this instance. So if I click on Share Session, It's going to copy the sharing link to the clipboard. So if I open up a new private window and go to that sharing link, you can see I'm able to spectate the running session in real time. And on the right side, there is also a really good chat feature where I can actually chat with the person who is actually hosting that session. There are lots of other cool stuff that you can do with Kasm. For example, if I go back to the main workspaces window, I get an option to actually pause this instance. So if I click on pause, that's going to pause my instance and I can resume it whenever I want. Or I can go ahead and delete that instance so that it is completely erased and no traces are left behind. So similarly, you can install multiple apps on Kasm from the official Kasm registry, which you can find if you go to the admin tab and then go to workspaces, click on workspaces again, click on registry, and this is going to display the list of apps that are ready to be deployed to Kasm. But you can also create your own custom images and deploy those to Kasm as well. You can do that by first creating a Docker image and then pushing it to Docker Hub, and then you can import that Docker image from Docker Hub to Kasm Workspaces by creating a custom image. And by doing so, you can stream any app that you want in a containerized environment from your browser with Kasm Workspaces. And Kasm is just a really awesome tool. It's free to use. It makes your life a lot easier because you can deploy containerized apps in the click of a button and also stream them directly from your web browser. All you need to have is a web browser, and that's it. So that will be all for this video. I hope you liked it. I hope you learned something new. If you did like this video, please do not forget to leave a thumbs up below. If you're not yet a subscriber, please do hit that subscribe button and also turn on the bell icon to receive instant updates from my channel. I'll see you in the next video. Until then, cheers.